Hi, I'm Christopher Desert, and I'd like to tell you about our new paper, Was There a 3.5 keV line? This work was done in collaboration with Ben Safdi, his graduate student Yujin Park, and Josh Foster. The 3.5 keV line is an X-ray emission line previously observed in galaxy clusters, galaxies, and the Milky Way, whose origin is unknown in standard astrophysics. Although there are proposed explanations, in this work we show that there is no robust evidence for the existence of the line at all. The goals of this work are firstly to reproduce the original evidence of the 3.5 keV line, following as closely as possible the analysis procedures used in their original works, and secondly to examine the robustness of that evidence to various tests for mismodeling. In this work, we reanalyzed 6 datasets that provide the bulk of the evidence for the 3.5 keV line. Our results are shown here for each of the 6 datasets we reanalyze. The discovery test statistic T is shown on the x-axis, which is approximately the square of the significance in sigma. The test statistics reported in previous works are shown as gray circles. For instance, the maximum Newton Perseus test statistic is about 17, corresponding to 4 sigma. In this work, we reanalyzed the data over 3 energy ranges, first in the original window and then in successively smaller windows. Surprisingly, we're unable to reproduce the results of these studies when analyzing in the original energy window, and we find no evidence for a 3.5 keV line in all but one of the analyses, maximum Newton CCO. Our results, shown as black stars, point to likely errors in those works, though we're not able to decisively identify the sources of error due to randomization in the data reduction. We believe that the errors are due to the use in previous works of local optimizers that returned results converged in a local rather than the global minimum. On the other hand, we use global optimizers exclusively in our reanalysis. We further analyze the data in narrower energy window analyses that are less subject to background mismodeling, and we find no evidence for the 3.5 keV line in any analysis, shown as the blue and red stars. We illustrate issues associated with background mismodeling and local optimization using mock datasets in section 2 of our paper, and we find evidence for the former in the CCO dataset where we recover a 3.5 keV line in the original window. I'm showing here our results on the real data taken by maximum Newton of the Perseus cluster. This dataset was first analyzed by Bolo et al. APJ 2014, who found a 3.5 keV line flux around 60 times 10 to the minus 6 photons per centimeter squared per second at 4 sigma by fitting the data in a 3 keV window from 3 to 6 keV, which is shaded in gray on the right. Our fit in that same window is shown on the left. We reduce and fit the data as closely as possible to the original analysis. Surprisingly, fitting over that same energy range, we find no evidence for a line. This points to an error in the original analysis, although, like I said, randomization in the data reduction means that we cannot compare precisely identical data sets. Note that we find that the randomization does not cause spurious evidence for lines, and over 100 distinct realizations of the data, we never find any evidence for the 3.5 keV line. We suspect instead that the original work fell into a local minimum that prefers a line rather than the global minimum that does not. And we obtain consistent results in the smaller energy windows where we also don't find a line. In summary, in no analysis do we find robust evidence for a 3.5 keV line. In the cases where we cannot replicate evidence even in the original analysis windows, we suspect that the spurious evidence in previous works was due to the inability of those analyses to reach the global maximum of their likelihood. In the cases where we find some evidence in the original window, that evidence goes away in smaller windows, strongly suggesting that mismodeling is at work. We're forced to conclude that there is no robust evidence for the 3.5 keV line at all.